You were saying that the opponent processing is causing each one to change, but it's not necessarily going anywhere. It's not necessarily making something better. It's just they're just changing each other.
Yes, so A causes B to evolve and B causes A to evolve, but they didn't create a higher level complex. So the thing that I think is missing there is to do with whether they find a harmonic relationship that makes a whole that's more than the sum of the parts.
But the harmonic relationship is really the core of your whole theory, then the necessity of that harmonic relationship.
Yeah.
Well, so say some more about that then.
So if you have a pendulum on a string, and you have a whole bunch of other pendulums of different lengths that are hanging off a common string. This is called Barton's pendulum. So if you swing one of those pendulums, it creates a little bit of wobble in there's the string that it's swinging on, but then there's the shared string that they're all hanging from. It creates a little wobble in that shared string. And that shared string is, just nudging all of the other pendulums which are hanging from it. Now, if there is another pendulum in that collection which is the same length as the one that you were originally applying energy to, then the wobble that it receives at the top of the string will resonate with the natural frequency of that pendulum, which means each time it's going this way, it gets a little nudge that goes that way. And each time it's coming back again, it gets a little nudge that's going back again. And those energies build up slowly over time. Just like swinging your legs on a swing at the playground, you have to get the swing of your legs in the same tempo as the natural frequency of your pendulum swing on the swing, right? Mm-hmm. So if the little nudges are the same frequency as the natural frequency of the pendulum, then it picks up over time, it picks up energy from those little nudges and it gets into a larger and larger swing. So that's a simple example of resonance where two things have the same frequency. But it turns out that another pendulum that can also pick up energy is a pendulum that is half the length, or a pendulum that is twice the length. And in those cases, it doesn't get a nudge every time it swings, but it gets a nudge every second time it swings. So it's not going to resonate as strongly. It only resonates half as strongly if it only gets a nudge every half a time instead of every time, but it still builds up energy over time. Now, in between being equal length and being twice the length, what's going to happen then? If you have something which has a natural frequency that's a little bit faster than the driving pendulum, then it gets a nudge when it's going forwards, and then it gets another nudge when it's going forward, but it's a little bit late, and then it gets another nudge when it's going forward, but it was really late, and then it gets another little nudge when it was coming back. So then it gets another little nudge when it was coming back, and then it gets another nudge when it was coming back, and then you wait a bit longer, it's getting another nudge when it comes forward. So the nudges are not building up properly, because sometimes they're building up and sometimes they're canceling out. And the net effect of that is that the pendulum that doesn't resonate doesn't build up. The energy doesn't build up in something if it doesn't resonate. So what are the lengths that do build up and the lengths that don't? Well, those are the harmonic ratios, right? It means that the number of swings you get on this one has an integer relationship to the number of swings that you get on that one. And if they have a ratio that's a simple ratio, like 2-to-1 or 2-to-3, the perfect fifth, then they will resonate to one another. And if they have a ratio that is, how should we put it, less harmonic, like 26/27ths, right? Then like nearly all the time they're canceling out. But if you wait long enough, there is a little bit of a residual that the product of 26 and 27, whatever that is, eventually they get back into the same rhythm again, and whatever that nudge was is in the same place again. But it's really, really weak now. right? That nudge, that resonance is really weak. So the harmonic relationships tell you about what kind of um, scale and frequency relationships communicate with each other, and what scale and frequency of relationships don't communicate with each other. And the interesting thing about that is that, there are big gaps. Like equal ratio communicates very strongly, 2 to 1 communicates half as strongly, 2/3 or 1.5 communicates the next most strongly. And in between that, there are big gaps where two frequencies just almost can't see each other at all. And that gives you a very particular but deeply mathematical structure to what kinds of things are natural, what kinds of things fit together, what kinds of things don't, what tensions are created when you play these two, but it's then begging for a third one to resolve it. That those mathematical relationships between those ratios and the leftover ratios, which are the complements or the beat or the difference tones between those frequencies, that's the language, right? That's the language of the physics. It's the language of music, but it's the language of the physics of the resonance between anything that's oscillating. And it doesn't matter whether those things which are oscillating or cycling are pendulums, or whether one of them is an electrical cycle between coupled neurons in your brain, or one of them is an electrical cycle between two cells with gap junctions in your tissues, or it's a gene regulatory cycle between two genes inside your cell, or it's a hormone cycle between your pituitary and your something else in your body. Whatever that thing is that's producing a cycle, if that's producing little nudges at a particular frequency, it will resonate with one of those other cycles if and only if it's in a harmonic relationship to it, or to the extent that it's in a harmonic relationship to it. So that gives you a way to connect cycles and rhythms and vibrations throughout an organism and any system that moves between substrates and moves between scales, that gives you a language in which some things are allowed and some things are not allowed, or some things create tension and some things beg for a particular resolution. That language is that mathematical language of the harmonies and the ratios gives you the constraint and the resolution that we were talking about in the art or talking about in the music. But that's the structural form of the the rules of living systems and learning systems.